Hi, I'm Karyn Hodgins, creator of Nifty Numbers, Math Medley, and Gelling with Geometry Family Math Night Kits. And in this video, I'm going to share with you my latest Family Math Night collaborative project, the Tetrahedral or Tetrahedron Kite. And this is the result of our collaborative project. Isn't that beautiful? And the best part is, it actually flies, and we'll get to that in just a minute. Okay, so if you've seen my other videos, you know that I'll describe the project first, and then I'm going to get into the math, and in this case, a little bit of the science as well. Okay, so the materials that you're going to need in advance are straws, lots and lots of straws, and I get my straws at Smart and Final, and I buy them in these big boxes, and they're already unwrapped. You're going to need string. I don't know if this is string or cord, but I call it string. And I also get this at Smart and Final, and it comes in these big, huge cones like this, even bigger. A lot of this has been used. But what I do to make it a little bit easier is I take a whole bunch of that and I wrap it around paint sticks like this. And I have a bunch of these set out on the table so that different people can use them at different times, instead of having a whole bunch of these on the table. Then you're going to need scissors, and I always have as many scissors as I expect participants at that station, or as many participants as the station can hold, actually. And then you're going to need clear tape and pens, and I like to use felt tip pens because it's easier to trace onto the tissue paper, which is the other thing that you're going to need, a whole bunch of colorful tissue paper. And I cut the tissue paper in advance to fit the template, which is another thing that you're going to need. And here is the template. So you can see in advance I've already cut out the tissue paper so that the template, and it does fit on here, you got to move it sideways a little bit. And then that way there's not as much waste for the tissue paper. Okay. Now the template can be found on our website at familymathnight.com under the resources section, and it's going to look like this when you get it. Okay, and the reason is because I can't fit the whole template onto one sheet of regular 8.5 by 11 paper. But what you're going to do is, it clearly indicates here where the fold is. You're going to cut this out, and it's going to end up looking something like this. And this is the top. You need to keep that in mind. This is the fold line. And then what I did is, because I don't have cardboard that's this long either, and you may not either, so I take two pieces of cardboard and I tape them together, and I use packing tape because these are going to get used a lot, and packing tape tends to last longer. And then I trace this on one side, you can see, just like that, and the fold is down here, and then that way, see how it goes like that. But I'm going to cut this out. When I cut this out, I end up with this, right, cut out, and voila, I have both pieces on there like that. Okay, so you'll need the template, and you'll also need, well, you'll find this very useful, the table tents, because the table tents are what the participants are going to use to figure out what to do at their station. Of course, there is going to be a station facilitator there helping as well, but it's a very, very popular station. So that station facilitator, or those station facilitators who you have there, are going to be very busy the whole entire evening. I can guarantee you that. Okay, so on the table tent, it clearly describes what to do. So the first thing it says make a tetrahedron pyramid, okay, using 6 straws and strings. So they're going to count out, nice little counting activity for those little guys. They're going to count out their 6 straws, and then they're going to make a tetrahedron. Now I have a whole bunch of these. This is what they're making, all right? And I have a bunch of these spread out on the table for them to use and pick up and look and see, and as an example when they're making theirs. Okay, so once they've done this, the next step says to choose your colored tissue paper. So on the very end of the table, I have all of those pre-cut pieces of tissue paper, and they can go and they can choose the color that they're interested in, and then they trace their template using that felt tip pen, and then they cut it out in the directions say to do that. Yes, use the template, then cut it out, and they're going to end up with something like this. Okay, looks like their template. So now what they need to do is they're going to tape your tissue paper onto the tetrahedron, see sample on table, because I do have a few of these samples on the table as well. And I'm not sure, right, oh here it is. So I've got a few of these already on the table for them to also look at. But to tell you how to do this, and I'm going to do it kind of holding, you're going to do it flat on the table, but for you to see, you're going to put your tetrahedron right in the center like that, okay? And then you're going to wrap these edges around, this is harder to do holding up like that. Wrap these edges around and tape them, and then flip it over, and then wrap these edges around and tape it. And then you'll have those two faces covered in the tissue paper. And then they hand that to the station facilitator, who starts to build the kite. Now, it's a very, like I said, it's a very active station. You probably will not get the whole kite built that evening, but what I discovered at my last Family Math Night event where we did this is that once you start building the kite, participants get super excited. And usually when I do these collaborative projects, there's a few kids and parents who make whatever it is that they need to make for the project, and then they get really attached to it and they want to take them home. What I found for this one was that everybody wanted to get their little tetrahedral cell part of the kite. So that was pretty interesting to see that, how involved everybody got in that. Okay, so now I need to show you how to put the kite together. I have started that over here. Okay, you're going to tape the cells. Okay, I call each one of those a little cell. Okay, so that it ends up looking like this. Okay, now you want to make sure that the faces with the tissue paper on them are all facing in the same direction. Can you see that? And then you're going to get string, and you're going to tie those vertices together. Now, I don't mind. This sample here, okay, doesn't have any strings hanging off of it. I actually really like it when they leave these pieces of string, because it makes it easier for me to tie the kite together. If they don't have the string, that's okay. You can tie string on here. It's just an extra step, but you can do it. Okay, so what's going to happen next is you're going to take one more tetrahedron. Let me move these out of the way. I don't know if you can see a little bit better this way. I'm going to take one more, and I'm going to tie it right to the top here, just like that. Okay, and then it's going to look like that. Okay, and by the way, this does fly by itself as well. A little, not as easily as this other one, but this size flies as well. And then we've got this one here. It's 1, 2, 3, 4, 5 different layers here. And obviously that one flies very well as well. But that's what's really nice about this project is with these leftovers, I get to create a smaller tetrahedral kite that will fly as well for the students. Okay, so let me talk to you about how it does fly, or how you need to put your string on to get it to fly. So if I can move this, okay, so that you can see the very top, it actually will end up flying in this direction. Okay, can you see? Like that. Okay. You don't need to do anything to make that happen. The wind will automatically do that for you. But what you're going to do is you're going to take the tippy top, and you're going to tie your string onto that. Okay. And then you're going to obviously have a very long string. Another option is to tie the string here, to loop it a little bit to about this point here, and then from there tie on your string. Okay, and that's just another option. And in fact, you can play around with those options and see which one works best for you. Then of course you have to wait for a windy day and then take it out there, and believe me, it's super fun and everybody wants to get a chance to fly it, which is nice if you end up with more than one. Here's a tip. Obviously this one has 5 layers on it. You need to keep in mind that you need to be able to, wherever you design and put the kite together, you need to be able to get it outside to fly it, right? So you need to make sure it gets through the door. So the larger you make it inside, the harder it's going to be to get outside. So just keep the width of your doors in mind as you fly your kite, because I learned that one the hard way my very first year of teaching. But that's what scissors are for. Okay, so now we're going to get into a little bit of the math and the science. So this little guy right here lends itself well to lots of great juicy geometry vocabulary. So I've been calling this a tetrahedron. It's also a triangular pyramid. But anytime you hear the word hedron in math, you know that it's going to be 3 dimensions. You're going to have your length, your width, and your height. When you hear gon, like as in polygon, you have your length and your width, so it's 2-dimensional. Okay, so this is a tetrahedron, and a tetrahedron is one of the 5 platonic solids, and a platonic solid is a solid, so 3 dimensions, length, width, and height, that's made up of the same polygon. In this case, it's our triangles, or our equilateral triangles, and you can get into the definition of triangles too, and then you can sort them by angle size. You can say, well, what kind of a this is an acute triangle because each one of those angles measures less than 90 degrees. You can even get into the interior angle measurement of all triangles, which is 180 degrees. I mean, you could really take this. You can see that there's a lot of math, right, involved in this one little guy here. Okay, so so it's one of the 5 platonic solids. So all of the faces are made up of congruent to the same polygon. It has, you can talk about the faces, it has 4 faces, it has 6 edges, it has 4 vertices, and so forth. Again, a lot just in that little guy there. All right, so now I actually do this, I've done this for many years in the classroom. I do this activity with 4th graders and up, where we build this kite, but I do it a little differently than I did it at the Family Math Night event. At the Family Math Night event, I told them, take 6 straws, okay, and turn that into a pyramid. In the classroom, I don't do that. So I have students working in pairs or with a partner, and I give them the directions, and the directions are, you are to build a pyramid using straws and string only. You can use the scissors to cut the string, but you cannot use the scissors to cut the straws. Okay? Your pyramid needs to survive the drop test. So I tell them I'm going to hold up their pyramid, I'm going to drop it, and if it doesn't collapse, then it has survived the drop test. And that's it. Those are the directions. I tell them that's all I'm going to tell you. So as the students get started, they're going to ask questions. They always do. And then I say the same thing. You are to create a pyramid using straws and string. You can use the scissors to cut the string, but not the straws. It needs to survive the drop test. I sound like a broken record after a while. And then they get to work. And it's interesting, you're going to get some different things. Sometimes you're going to get students that create a little teepee-like pyramid where they just get a bunch of string and they just tie it together, and it creates a little like teepee thing. And then of course you're going to talk about the characteristics or the attributes of pyramids. You know, does that fall into that category? And no. Okay, so let's go back to the drawing board. And then you're going to get some students to create a square base pyramid, okay, like this, or an Egyptian pyramid, right? There's square base on there, okay. And that's great. This is exactly what I want. I want some students to do this because now I'm going to test it and see if it survives the drop test. And it's interesting because the kids will try it first, right? They want to make sure that their pyramid survives the drop test. So when they build one like this, they usually come to me and say, okay, Mrs. Hodgins, you need to hold it up here and then drop it. And I say, oh no, I can hold it wherever I want to hold it and drop it, which is exactly what I do. So I turn my pyramid like this and I drop it, and it's probably hard for you to see, but there it is. It's collapsed. It did not survive the drop test. And this is a beautiful way to segue into what makes, why did this pyramid collapse? And by the way, I make it very clear that this is absolutely a pyramid. It's a square-based pyramid. Okay, we can talk about the faces and the different polygons that make that and so forth, but absolutely it is a pyramid. It just didn't survive the drop test. Why? Because it collapsed. Why did that happen? Well, when I push on these vertices here, okay, it's not very strong. And then I get to talk about what could we do to make it strong? And then students will come up with the idea of, well, we need to put a straw there, but it wasn't long enough. The straw didn't fit across there, and so forth. And I said, well, if I had let you cut the straws and put them together and tape the straws and whatever, could you have made it sturdy? And yes, indeed, they could have. And then we talk about the triangle being the strongest geometric shape. And the reason that's important is because later we're going to do another project where students build the tallest structure, and they're going to use that information to help them build the tallest structure. Okay, but back to this. So this is a great problem-solving activity to do in the classroom because it allows students to figure out and solve the problem on their own. And by the way, I call this one my porta pyramid because I could just collapse it and throw it under my arm and take off, and it's portable. They get a kick out of that. So, all right, so now I'm having students build the tetrahedrons because I tell them, so I didn't tell them in advance that we were building a kite. Now I tell them, well, we're going to turn these tetrahedrons, if everybody could focus on making these tetrahedrons, we're going to turn it into a kite. So I get them all focused on that part. I do offer for students who have made their tetrahedrons, if they want to create a cube now, figure out how to use the straws and the string to create a cube. And this time it's okay if they want to, they can cut the straws if they find that helpful. All right, so now I usually do this project in the spring, usually around testing time, because it's a great way for them to kind of relax and de-stress after the intensity of testing in the morning. So it's a great spring project. And then I move right into a unit on aerodynamics. So aerodynamics, now we're going to get into a little bit of the science. So aerodynamics is the study of the science of flight. And whenever you have flight, you need four forces. You need your lift, your gravity, your drag, and your thrust. Okay, so we know what gravity is, right? Things fall down. Drag is when things kind of slow down because it's moving through the air. Then you have your thrust, okay, the thing that moves it forward. And then you have your lift. And of all of those, the one that's the most fascinating to me is the lift, because if you think about this, you have a 200-ton piece of metal in the sky that we call an airplane, right? Why doesn't that thing go plummeting to the earth? Well, it's because of those four forces. But the one, again, that's the most interesting to me is lift, and this is where we get into Bernoulli's Principle. So Bernoulli's Principle states that the faster air moves, the less pressure. Okay, and I want to share this with you. This is how I describe it to the students in the classroom. So if you're looking at an airplane, you're looking straight on to the fuselage, the long part of it. Okay, so the wing's coming out at you, right? If you take a cross section of that wing, it might look a little bit like this. Okay, and this would be called, this part here, that curved part, the camber line. So what happens is Now remember, I'm talking to students here, so I'm trying to get them to understand this idea of Bernoulli's Principle. I tell them a story about two little air molecules that are super good friends, okay? And they've been hanging out together, and then they come upon this structure. And one of them ends up going in this direction, and the other one ends up going in this direction, but they want to meet together, right? At the other end. They're best buddies. So I asked the students, there we go, I asked the students which one of these little guys has to move faster and has a longer distance so that they can meet together at the other end. And of course it's this guy right here, right? He has to move a lot faster in order to meet this guy who's moving in that direction. And then there they go at that end. And so what happens is, because this guy is moving so much faster, it creates less pressure. So now there's more pressure underneath here, underneath the bottom of the wing. It's kind of like a suction. It just kind of sucks it up, which is why those things can stay up in the air because of that lift. And I have to tell you this, it's a true story. Shortly after we did this unit on aerodynamics, the students were participating in the science fair, and that's something that the teachers at that particular school didn't get involved in. So it was something that the kids did with their parents. And so in the evening, they display all of their projects. And one of my students was fascinated with this unit, and he wanted to do aerodynamics as well. And so I'm walking around to the different tables, reading all their little reports, and I come upon this little guy who has written his report on aerodynamics. And when I'm reading his report on lift, in his report, he's writing about these two little air molecules that meet at the end of the wing, and they want to meet again at the other end, and yada, yada, yada. So super, super funny and super fun. And that is why I love teaching, because of things like that. So this is a great project. It's a super fun family math night project, especially because the kids are super excited about being able to fly this. Of course, they now need to wait until one today, but they will be flying this, and it's going to be really fun. So enjoy it.